Here is a combined summary of pages 14 of the research paper. Self-supervised learning has shown promise in training generalizable models on large-scale data in various fields, including vision, text, and speech. However, its application to music audio has been limited due to the unique challenges of modeling musical knowledge, particularly tonal and pitched characteristics. To address this research gap, the authors propose MERT, an acoustic Musik und Erstanding model with large-scale self-supervised training. MERT incorporates teacher models to provide pseudo-labels in the masked language modeling style acoustic pre-training, which outperforms conventional speech and audio approaches. The proposed model combines an acoustic teacher based on Residual Vector Quantisation Variational AutoEncoder, RVQ-VAE, and a musical teacher based on the Constant Q Transform, CQT. This multitask paradigm balances acoustic and musical representation learning, capturing the distinctive pitched and tonal characteristics in music. The context dependencies and music hierarchies are modeled using stacked layers of self-attentions in the transformer. Experimental results indicate that MERT can generalize and perform well on 14 music understanding tasks, achieving state-of-the-art overall scores. The authors also explore a wide range of settings to overcome the instability in acoustic language model pre-training, allowing MERT to scale from 95M to 330M parameters. The authors argue that the benefit of MERT is twofold. It can unify the modeling of various music understanding tasks, and it allows for the redistribution of musical knowledge rather than the data itself, saving costs of manual annotation and copyright law restrictions. Furthermore, the research paper discusses the development of pre-trained language models for acoustic music, focusing on improving open-source, generalizable, and lightweight learned representations. The authors propose adapting self-supervised speech processing models for music audio processing tasks, leveraging the common grounds between music and speech processing. They introduce a masked language modeling approach, similar to Hubert, but tailored for music with additional music-specific features and augmentations. The methodology involves pre-training with MLM and modeling acoustic information using K-means or deep learning-based approaches. The research paper presents a novel self-supervised learning approach for music audio, introducing MERT, which leverages masked acoustic modeling and musical information reconstruction to improve the generalization capabilities of pre-trained models on various music information retrieval tasks. By employing a K-means teacher for acoustic features and an N-codec teacher for musical information, MERT effectively captures both local and global musical patterns. The proposed model is trained on a large-scale music dataset and evaluated on 14 downstream tasks, including music tagging, key detection, genre classification, emotion score regression, instrument classification, pitch classification, vocal technique detection, singer identification, beat tracking, and source separation. The evaluation protocol includes a fair comparison with baseline models from both music and speech domains. The authors discuss challenges encountered during the scaling up of acoustic encoder-only models and attempt to mitigate these issues through various methods. Despite these challenges, MERT demonstrates strong performance on a variety of mere tasks, showcasing the potential of self-supervised learning for music audio. The proposed MERT model leverages the constant Q transform, CQT, as a musical teacher to introduce harmonic inductive bias during pre-training, achieving significant performance gains on tasks such as key detection, genre classification, and emotion recognition. By replacing the acoustic teacher with the RVQ-VAE model and codec, MERT reduces the cost of scaling up K-means while maintaining similar performance. The study on musical loss reveals that a weight of 1 yields the best overall performance for the base model. The integration of RVQ-VAE and CQT teacher models provides a unique blend of acoustic and musical information necessary for masked language modeling-based pre-training for music understanding. This approach, combined with in-batch noise mix-up data augmentation in pre-LN, enables the learning of robust music representations with further training stability. MERT surpasses previous SSL baselines, achieving state-of-the-art or comparable results across a wide range of music information retrieval tasks while using significantly smaller parameter sizes. The paper provides a comprehensive overview of various techniques and models used in music information retrieval and audio processing, including the importance of familiarity in background music, end-to-end musical key estimation using convolutional neural networks, and deep learning for symbolic mathematics. It also explores transfer learning with deep neural embeddings for music classification tasks, highlighting the significance of hybrid transformers for music source separation. The authors discuss the effectiveness of speech self-supervised learning for music, the universality and diversity in human song, and the use of decision transformers for reinforcement learning via sequence modeling. They examine the Music Demixing Challenge 2021 and the evaluation of algorithms using games such as music tagging. The paper also addresses the calculation of a constant Q spectral transform and the role of large-scale self-supervised pre-training for full-stack speech processing, emphasizing its potential applications in music information retrieval. The research paper discusses contrastive learning of general-purpose audio representations, focusing on robust representation learning through in-batch noise mix-up. It introduces a novel mix-up augmentation, where an audio clip is added with a certain ratio of shorter audio excerpts to form an augmented single sample during pre-training. This approach enables the learning of more robust musical representations. The methodology is detailed, including the pseudocode for the pre-training loss calculation. The paper also presents an evaluation study on the impact of in-batch mix-up probability, concluding that a probability of 0.5 is suitable based on average performance scores. The results demonstrate the effectiveness of this approach in enhancing musical representation robustness. Additionally, the paper evaluates the effectiveness of the vanilla RVQ-VAE embeddings and shows that they are insufficient for a robust music understanding baseline. The MERT pre-training significantly enhances the performance in various downstream tasks such as music tagging, key detection, genre classification, emotion score regression, instrument classification, pitch classification, and vocal technique detection. The MERT series consistently outperforms the RVQ-VAE model across all tasks, highlighting the significance of the pre-training method in improving the model's performance. The paper presents a comprehensive evaluation of the MERT 330M model, focusing on its performance in music information retrieval tasks such as singer identification, beat tracking, and source separation. The authors utilize the extracted features from the pre-trained model as input for training a shallow supervised model on each task. For singer identification, an MLP with one hidden layer is employed, while for beat tracking, a dynamic Bayesian network is used. In source separation, the MUSDB18 dataset is utilized with a baseline architecture from the Music Demixing Challenge 2021. The paper discusses the instability encountered during the training of the MERT 330M model under mixed precision training and explores several settings to alleviate instability. The authors also visualize the GTZAN representations with genre annotations, revealing a pattern of clustering according to genre information under different layer settings. The findings suggest that the MERT models capture genre-based information, but the relationship between the representations and the MLM pre-training objectives warrants further investigation. The research presented in these pages focuses on pre-trained representations of the GTZAN dataset using the MERT 330M RVQ-VAE model. It begins by detailing transformer layers from 17 to 20, showcasing their representations through figures. The methodology and its significance are highlighted, emphasizing novel ideas and significant findings. The content then transitions to transformer layers from 21 to 24, presenting their representations through figures. The summary connects the content of these pages, illustrating the flow of ideas and emphasizing technical aspects, such as equations and algorithms, with precision. It also highlights limitations and future work discussed in the paper. The study's focus on understanding music automatically is believed to contribute positively to both social and scientific outcomes. Ethical considerations are emphasized, ensuring personal user information was not used, and audio recordings were collected from open access streaming services and open source datasets.